Let's go over the solutions to the practice test that you have on Canvas. On the first page, we're looking at this molecule right here. We're going to use it to answer the first 6 questions, classifying it because the carbon-oxygen double bond is on carbon number 1 and it's an aldehyde. This is an aldose. The number of carbon atoms total in the molecule is 6, which makes it a hexose. We could put those together and call it an aldohexose. Classify this molecule. That's going to be based on the direction of the OH group on the second to last carbon. So for us, for this molecule, it's carbon number 5. Carbon number 5's OH group is pointing to the right, which is D. If it's pointing to the left, it's L, and we can only use alpha and beta when we're looking at the cyclic structure. Draw the structure, the Haworth structure of the molecule. So when we're drawing this structure, remember we always make this guy right here as carbon number 1. Let me set my ring up better. Next guy is carbon number 2, 3, 4, 5. Up here is carbon number 6, CH2OH. And so carbon number 1 is what dictates alpha versus beta. So it's our choice of where we want to put the OH group on carbon number 1. On carbons 2, 3, and 4, we have to look at the position of the OH groups in the straight chain version of the molecule. We want to imagine turning it on its side this way. And if we do that, on carbon number 2, the OH is down. On carbon number 3, the OH is up. On carbon number 4, the OH is up. And the molecule that we drew in problem 3 with the OH group on carbon number 1 up in the sky is a beta. Draw the product when the molecule in the box is going to be reacted with Benedict's reagent. Benedict's reagent is going to convert the carbon-oxygen double bond aldehyde to a carbon-oxygen double bond carboxylic acid. But it's not going to change anything else about the molecule. So our OH groups are going to be right, left, left, right. As we go down the carbon chain, right, left, left, right. Like that. And for the disaccharide on the right, describe the glycosidic bond using the correct Greek letter and the correct numbers. So to do the alpha or beta, we're going to look at the 2 carbons that are involved in the glycosidic bond, and we're asking ourselves, are either one of these carbons anomeric? Are either one of them carbon number 1 of their own ring? This guy is carbon number 1 of its ring. This guy is 1, 2, 3, 4. So because this guy is carbon number 1 of its own ring, we will use it to determine alpha versus beta. Its oxygen is sticking up, which makes it a beta. And then for the numbers, we just want the numbers of the 2 carbon atoms that are involved in the bond, beta 1, 4. Describe glycogen. Glycogen is a polysaccharide. It is a branched structure, and it is used by humans to store excess glucose. That's just stuff that's in your notes or in your brain. Use these amino acids to answer questions 8 through 10. Draw the structure of glycine. So we have glycine over here at a low pH. A low pH is an acid, and in a low pH, we're only allowed to have positive charges present on our amino acids. So that means we want to redraw this molecule. We can keep the positive charge on the nitrogen, but on this carbon, COO minus, that has to be converted to COOH. Draw the structure of aspartate at pH 14. So that is a high pH. That is basic, and because it's really high, that means we can have as many negative charges as we need to, like negative charges everywhere. So it looks like this one that I'm working on might be a little bit different than the one that's actually posted on Canvas, because I'm looking at the one on Canvas and it says pH of 4. So I'm going to do 14, and then you have the solutions on Canvas that say 4. So you can You can go with either one. I got distracted while I was looking at that. So we need to convert the NH3 plus, that has to be neutral. We can have negative charges everywhere else. Draw the structure of the peptide with the formula GLY-ASP-GLY. So for this, we want to set up 3 amino acids. There's amino acid number 1 right there. Now we're going to set up amino acid number 2. And then we're going to set up amino acid number 3. And this is our last amino acid. So it's going to have the oxygen with a negative charge at the end. And then on all of our CH carbons, we need to put the R group of our amino acids. GLY, R group is just a simple hydrogen, and we've got one of those at the beginning and one of those at the end. And then ASP has the CH2, COO minus, R group. So there's that peptide. Describe a protein's beta pleated sheet. The beta pleated sheet is part of the secondary structure. It has a flat folded shape caused by hydrogen bonding. All of the secondary structures, or both of the secondary structures, are caused by hydrogen bonding. What's true about the tertiary structure? It is more stable, so every structure becomes more stable. Secondary is more stable than primary. Tertiary is more stable than secondary and primary. It contains multiple primary strands. That is not true. That's a quaternary structure. It's caused by interactions between the R groups of amino acids. That is true. It's caused by hydrogen bonding between amino acid. No, that is secondary structure. List any one thing that could cause protein denaturation. It can be caused by chemicals. It can be caused by heat. It can be caused by agitation, stirring, shaking. That's 3 things. Fill in the table to describe DNA and RNA. Which one contains millions of nucleotides is DNA. Parent to offspring, DNA. Phosphate group, they both have phosphate groups. Monosaccharide, they both have monosaccharide. Single strand, that's RNA. Fill in the table to describe the nucleoside bases found on the nucleotides in DNA and RNA. Some rows may require you to check more than one box. DNA has A, C, G, and T. RNA is A, C, G, and U. Ones that can pair with A, that's either T or U, depending on if it's DNA or RNA. G pairs with C, T pairs with A. Circle the portion of this molecule that's part of the phosphodiester bond. So the phosphodiester bond is this piece right here that's connecting the 2 nucleotides. Very briefly describe the fundamental differences in function of the RNAs. Our RNA makes ribosomes, makes up ribosomes. mRNA carries instruction from DNA to the ribosome. tRNA carries amino acids to ribosomes. Write the complementary strand of DNA. So this is DNA complementing DNA. ACT, GCA, CTA. Write the mRNA strand synthesized from that DNA template. C, G, C, U, G, C, ACU. Write the amino acid sequence that would be synthesized from the following mRNA. So the first 3, AUU, is ILE. The second one, CCC, is PRO. And the last one, AUA, is also ILE.